to take a bus. Because there is only one bus.
Okay.
82.
Okay. Yeah, when I moved to the Netherlands, I took a course of the Dutch language, and in my class it was like a couple from Vietnam who live in the Netherlands.
Yeah, Vietnam live everywhere in the world. Here in Houston, a lot of Vietnamese here.
Yeah.
They live in a town, you know, they live together in a community, Vietnamese community. And
Music, 82.
yeah, only one bus. Yeah, so it's easy. Oh, hi.
What?
I thought you already there in the morning.
No, I didn't get the bus.
Oh, you didn't get the
I
bus?
missed it.
Oh.
So I had to wait.
Thời tiết rất là tốt. Space Center, Houston. Đã nữa. Good. Stop here.
49, Monday, Cuban, Gary, Westwood, Monday, Cuban, Gary.
What is it? Okay. Yeah, thank you. Hi. So, goodness.
You should walk.
Maybe I will. I'm the first time here, so. Closer, closer. Closer.
Welcome to NASA's Johnson Space Center, one of 10 NASA field centers and the heart of human spaceflight operations for the past 50 years. It is here that history has been made and will continue on as the men and women of NASA push the boundaries of exploration.
You are now leaving a museum and entering the Lyndon B. Johnson Space Center, the home of human spaceflight and home to the thousands of dedicated men and women who work here. This isn't an exhibit or a theme park. This is the real thing. I'm Gene Sun, an Apollo astronaut, and it is with great pride and pleasure that I welcome you on this tour. What makes the Johnson Space Center special is that the elite men and women who go into space work and train here. What makes us successful is the team, the astronauts, and the people who support them. From the largest indoor underwater training facility in the world to the operation of the largest orbiting science laboratory, the International Space Station, Johnson Space Center has always been on the leading edge of discovery and innovation. but not for long. Right?
Humans have always had a basic inborn need to learn, to understand.
Johnson Space Center. Welcome.
Did you ever wonder what the Johnson Space Center looked like back in the 1960s? Before the center was built, it was a pasture for cattle. You'll notice some longhorn cattle to your left as we enter the JSC grounds. This area is now used as an educational opportunity for students learning about agriculture and farming.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard.
John F. Kennedy gave this rousing speech at Houston's own Rice University in 1961. Rice provided 1,000 acres for the new NASA Center, land that had been donated to the university by Humble Oil Company, now ExxonMobil. Additional land, just over 600 acres along what is now NASA Parkway, was bought for $1
engineering. So many young and extremely brilliant people walking around these buildings. That's largely how we got to the moon. I'll tell you about the little technology.
All right, ladies and gentlemen, we're approaching the final stop of the tour today, Rocket Barn. Please remain seated until the tram comes to a full green stop. Then exit off the left side of the tram and the left side only. This portion of the tour is self-guided and a new tram will be by in about 10 to 15 minutes, so feel free to spend as much time here as you like, and you can take any tram back to the space.
Except for I got my exercise, I walk up like 6 flights of stairs. They live in Bangalore. How are you guys? You live here. Bangalore? Oh, this is still in Tata office. Retired. I'm retired. I'm 63. Okay. I forgot to call Gary yesterday for his birthday. I'll do that. Okay. Okay. Alright. Well, here, I'll just look. On Saturday, I'll with Jonah real quick. Try to catch up with him.
And then, you know, like he told you, there was only so much electrical power on the spacecraft, and they only use it for enough minutes to make sure they can get the capsule in the right angle for the landing. Oh. Especially Neil Armstrong.
the picture. So buy the ticket here. Combo 36 regular. What's the difference between combo and regular?
Yeah, I don't know. The combo is with audio and the other one is without audio.
Without something, but I don't know which one. Audio tour, huh?
Yeah. Oh, you're going to do it with audio or without?
Make sure it's necessary or not.
The regular ticket?
For how many? Just one?
One, yes.
Will be $29.95. There you go. You can sign that. There you go, sir.
The regular answer.
Will be $29.95.
Yeah.
Every 30 minutes. No, you can do it. There you go, sir.
This is the ticket. The ticket.
Okay, what do you guys think I can
Thank you. Come on in.
Cup of water. How are you going to take your cup of water and cool yourself down? You had to come to the show, didn't you? I could drink it or I could pour it on my head. What do you want to see me do? Pour it on my head? Yeah, drinking it wouldn't be any fun at all. And guess what? I'm not going to be the only one who gets wet. I'll see. Look at you two. Blame those guys back there. They're the ones. Yeah. Okay, so now it's my turn. We're all going to count down together. That's the only way. Okay, are we ready? Here we go. 3. Water. And now I'm going to use them as my spare parts in case I have an accident. Well, maybe I could give you a hand or lend you a ear. Okay, so inside my cup, besides the water and a little bit of air, what was that stuff I put in there? Does anybody remember the word? Holy moly! You almost got the whole thing. Super hydrophilic polymer. Excellent. But this super slurper isn't a body part. It's actually in the form of a powder. And I put the powder in the cup before you got here. I poured in the water, and this is what we have now. Kind of looks like ice, right? It's actually a very pliable gel. Take the powder, we mix it with cotton, we put it in disposable diapers. Yep, then when a baby wets, of course, it slurps up all the liquid. But see, it's very pliable, so the baby doesn't have to sit on a lump. But that's how disposable diapers work, and I call that an FYI. What's an FYI? For your information. That's right. Once those air molecules begin to expand, they are going to start getting farther apart, right? And some of them are actually going to escape the bottom. Now I'm going to put the balloon back on top, and when I do that, it's going to leave the inside air pressure lower than the outside air pressure, which will be greater. And since air pressure needs to be equal, the outside air pressure being greater, of course, will be pushing on the balloon. Ta-da! You make better air pressure!
You do that with an egg.
Oh, sorry. Well, look, we do have a water balloon in a bottle. All right. Now, I really like bottles, as you can probably tell, because I got a couple more. Can you tell me what's inside these bottles? Ooh, balloons. But is that all that's in there? Ah, for this demonstration, I require 2 volunteers, but you have to be able to blow up a balloon. Oh, that young lady says she can blow one up. How about that young man right there? Yep, come on up here. On the inside of the bottle. This looks like a competition, doesn't it? Yeah, but everything on my stage is a demonstration, so no matter what happens, you're both going to be winners, okay? Cool. All right, so here we go. Are you guys ready? On your marks. Get set. Amazing, isn't it? Hey, what's inside these bottles again? Air. Well, that explains it. Air is matter. It has mass, and guess what? It occupies space, right? Nobody can blow up this balloon because this bottle is already full. What's it full of? Air. And if we put candy in the bottle all the way to the top, we wouldn't be able to put any more candy in it, would we? No, it would be full like it is now with air. But wow, you're Superwoman! Well, actually, this bottle has a hole in the bottom. And that is why you can blow it up. Because if we put candy in this bottle, but it had a great big hole in the bottom, what would happen to all that candy? It would, but with a tiny hole in the bottom of the bottle. What do we have on the inside of our bodies? Our heart pumps it, and it turns red when we get cut. Blood. And what does blood carry to the cells in our body? Air or oxygen, that's right. But you know what? I couldn't find a donor today. Nobody would give me their blood, so I had to make my own. I had to make my own out of water and food coloring. What is the molecular structure of water? You guys all know. Let's say it together. H2O. What's the O stand for? Oxygen. There's air in here. I need a very brave volunteer. Okay, come up here.
All right.
Come here. Let's see how brave you are. Come on over here. Turn around, face the crowd. We're going to do a dance. Just kidding. We'll do that later. I need you to take one finger. Take the tip of that finger, dip it in there. Hot or cold? Cold, he says. Hang on a second. Ooh, your hands are nice and warm though. Guess what? That was the right answer, and you're doing really good. Now tell everybody how brave you are. You're super brave. See that? Super brave! He's going to stay up here and help me some more, right? Okay, cool. Hang on to that. Don't lose it. Go. Stay right there. No, but that's only part one. Uh-oh, there's a part two. Why do you think you're holding that? Somebody's got to be brave enough to put the finger in there after it boils. That would be you. Shake your head yes. Okay, good. What's it doing? It's boiling. Check out the boiling blood. It's in outer space without a spacesuit. But you can't touch it unless we take the lid off. And the only way we can do that, we have to let the air back in, which is called repressurizing. We're going to do that right now. You're going to stand here by me. Put your finger down here like that without the paper towel, please. That's good because, you know, all we're going to burn, all we're going to put in is just the very tip of your finger, okay? Stay there, don't move, all right? I'm going to bring it to you. That way we'll be really, really safe. Okay, it's just a tip. Okay. Ready? Ah! What do you mean it's cold? It boiled. Boiling water gets hot, right? Well, it's not on a stove, so it's never really boiling. But what did we do? We removed the air that was pressing on the air inside the water. The air inside the water had a chance to expand and come bubbling out, looking like it was boiling, and now you get to dance with me. Because it's kind of boiling. There you go. Good. Give him a great big round of applause. He was excellent. Black one. There you go. And you're my bestie, and you can plug it in. Good job, young man. I think he's shrinking. Are you shrinking in there? How come he's shrinking? He's in space. He should be getting bigger. Well, we're going to bring him back to Earth and repressurize and try to figure out just what's going on. You suppose this is why he did not want to go in that vacuum chamber. Inside marshmallows are tiny little pockets to get the action. So which direction is the action going to be going? What are we throwing?
Air.
Oh, the air. That's our mass. We have to throw the mass. Which direction is it coming out of the balloon? Down. So the action is down. It's because of that action that we get what? The fun part or the reaction. So let's all count down. Here we go. 3, 2, 1. Blast off. All right. Up we go. How? You coming down or are you going to stay up there today? Well, I think it went behind the thing. Yeah. I'll worry about it. Some variables, and you'd be able to graph it or chart it. And that's why vinegar and baking soda would be easier because you can actually measure them better. But I like to use this. I'm going to break it up, and I'm going to put the whole thing in there. And once I do, pop the lid on. I'm going to put my rocket down. And what are we going to see? Action, reaction. So keep your eyes open.
Wow.
All the same. All right, but I want to show you that all of our action is. All right, I'm gonna bring this back here. What's the first thing I have? Oh, I have a very flexible rubber band. How quickly is it gonna freeze in the liquid nitrogen? Well, that's what we're about to find out. We're gonna count down. Ready? 3, 2, 1.
Cold.
Yep, that's frozen. Now I blew up this balloon and I put it on a test tube, and I'm going to put the test tube inside the liquid nitrogen. What's that going to do? Well, what's going to happen to those air molecules inside the balloon? They're going to start getting cooler? Yeah, what happens when they get cooler? They start to condense or contract, getting closer together, and that's going to go from the state of matter, gas, into the next state of matter, which is, begins with the L. Liquid, that's right. So guess what you're going to get to see? My liquid breath. It's really cool. All right, what else we got? A board and a nail, and I'm going to hammer the nail in the board. See, I have a hammer, but wait. Now I also have a very light and flexible racquetball, and I have a hammer. Let's see how flexible it is. Look at that. We can still play racquetball, but I'm going to put in liquid nitrogen, so what's going to happen to it? Did I hear freeze? Yeah. And it's really light, so is it going to sink or float? Sink or float? Float! Oh no, look. The balloon is shrinking. We're going to have to count down. Here we go. 3, 2, 1. All right, it's ready now. Very, very quickly. Take a look at the bottom of the test tube. We're going to see a white liquid. It frosts up really quick, so get a look. And it evaporates really quickly, too. So you got to kind of look at the very bottom. Just a little bit in there. But what's happening to the balloon? It's getting blown up. Who's blowing it up? Whose air is it? I'm blowing it up, and I'm talking to you at the very same time. Science magic. All right, I have a lime in here, and ta-da! You may clap for liquid nitrogen. Yeah, pretty cool. Maybe some limeade later. 2 points. Wait, I forgot to tell you something. At the end of this show, there's going to be a quiz. It's only one question, and I know everybody can get the answer because it's on the screen. Just know it's the top numbers. They're yellow, and they're negatives. Negative 321 Fahrenheit, negative 196 Celsius, and don't forget, because I'm going to ask you to guess. Okay, I have a racquetball in here, and the last time I hit the racquetball, what happened? Bounced right off. Okay, so we're going to count down. Here we go. 3, 2, 1.
Oh.
Oi. Let me grab a piece. Look, no racquetball. Okay, I have just 2 things I want to share. I think I have a secret admirer. I want to find out.
You take some really, really cool shots of everybody in the air.
Both bone as well as muscle mass. It's kind of like an accelerated aging process up there. So to counteract that, we use physical exercise. We require that people do 2 hours of exercise 7 days a week, no matter what. And even with that exercise, it's for all of us.
That's part of the training, because the ISS is not just a place to live, it's a space laboratory for all kinds of new research, and I'm hoping that you will help us out with some of that research. You ready for that? All right, come with me over here. I need you to put your back against this wall for me right here. Stay with your arms down at your sides, extremely still, okay? I'm gonna give your body a quick scan so we can see what's going on in there. I promise this is only gonna hurt just a little bit, and it will only leave a small, permanent mark. But we never know where that permanent mark is gonna turn up, so you're gonna have to check yourself when you get home later tonight, okay? Just kidding, don't worry. All right, these readings are looking good so far, but before we finish your training today, I'm gonna ask you to return to your seat back down there on Earth so you can see what we're gonna do with your body scan, okay? So head back to the steps, be careful on your way down. Give them a big round of applause, ladies and gentlemen. A highly scientific name for this, they call it chicken legs. Now your bones are gonna start to lose calcium. Your spine is gonna grow 2 inches. Also in microgravity, your heart, that's going to shrink up just a little bit. Don't worry though, because when you get back here to Earth, your heart gradually returns back to normal size. But with calcium loss, among other things, the recovery for that is a bit more difficult. And that is why our astronauts are all willing test subjects, helping us to understand how reduced gravity will affect long-distance space travelers. So in other words, before we go all the way to Mars, we're going to need to find a way to prevent osteoporosis. Now, biological processes aren't the only things that behave differently in microgravity. Chemical reactions, those will behave differently as well, and I have a couple of those to show you. So take a look at this candle flame. Look at the shape of the flame and how it appears. You can see that, if it appears, hold on. There we go. Now you can see that it's got that raindrop shape that we're all used to seeing on Earth. If you've ever lit a candle, if you've ever seen a candle burn, you know that the flame looks just like that. But have you ever wondered why it does? Well, here on Earth, fire makes the air hot, so it rises. This allows other cooler air to rush in and take its place. This process is known as convection, and it's why the flames here on Earth take that shape, rounded at the bottom, but pointy up at the top.
Vegetable. Yeah, veggie. And egg.
We did not realize that it was built as the same material as the space.
Çok çektiysem sil bari. Şunu çek. Yok şey. Neyse sen gelmesin yani. Şunu da istersen çekeyim. Bu da böyle olmuş. Onların kullandığı şeyleri.
Look at your good shot. It's your one or the other. Just because, but I'm not terribly I'm not Eric, look. I'm fine. Look at everything here. Look. He's washing his hands. Look how that happens, Eric. It's gravity.
Is this toilet?
This looks like a bedroom. Yeah.
So here's this and here's NASA S.
Yeah.
All kinds of technology.
You want to turn around so I can take pictures of you?
Yeah, really, basically only enough.
It was a 3.5 radio operator.
Communities for International Space Station can be different because trained medical personnel are not always available. NASA research teams develop techniques that enable astronauts on the space station with minimal training to operate an ultrasound device using simple printed catheter. The ultrasound images are transmitted in real time to a doctor.
Ah, puedo tomar una fotografía. Hay que ver. Ahí está la foto. Ah, sí es una cámara. ¿Qué? Ah, sí, sí está. A ver, ¿qué es lo Listo. Mira nada más que suculento. Ok, va la foto. 1, 2. A ver otra vez. Oh, suculento.
Cơm cũng bự luôn.
This is the one that the chef in the book had.
living in, exploring, and experimenting in a microgravity environment. The station spans the length of an entire United States football field. It's traveling at a speed of 17,500 miles an hour, or 28,000 kilometers. For the past 16 years, someone has been living and working continuously in space aboard the space station. And for that reason, we owe a huge thank you to our space shuttle program. Without the shuttles and their ability to carry heavy payloads into space, the building of the space station would have been next to impossible. Now, the shuttles ran for a total of 30 years and had 135 launches before they were decommissioned in 2011 upon the completion of the space station. The orbiters, or the shuttles themselves, were then placed into various museums located throughout the United States.
Oh, sandstorm. You see all the sand? Straight. That's what we're on. What's it?
That doesn't look comfortable.
It's not. I thought we were supposed to launch. Oh, there's no padding on it?
Nope. That's it. Alright, come on guys.
No, we're shaking.
Oh, you're shaking? You guys are taking off. Okay.